Thanks for sticking with. We have two more examples for 11.4 notes. Feel free to use whatever formula you'd like in order to find the area of the regular polygon. So for number 9, we want to find the area of a regular hexagon that has a side length of 12. Now drawing in the triangle here, each of these central angles is going to be 60 degrees, and that's going to make this an equilateral triangle. So I can actually nicely find the area of that equilateral triangle by doing s squared root 3 over 4. Once I know that area, I'm going to go ahead and take and multiply it by 6 to find the overall area of the regular hexagon. Due to this and simplifying it, my final area then would be 216 root 3 units squared. So for this one, it was a little bit nicer to just find the area of one triangle and multiply it by the number of sides or the number of triangles. Let's take a look at something different. The regular decagon, it has an apothem that has a length of 13. So if I were to draw in my triangle, I could draw in the apothem here. Again, it's the perpendicular distance from the center to the side. That has a length of 13. I can find my central angle by doing 360 divided by the number of sides, which is 36. And my apothem is going to bisect that angle, which makes each of these angles up here 18 degrees. So I'm going to go ahead and try to find this distance down here along the side. I can do that by taking the tangent of 18 equals x over 13. So x would equal 13 times the tangent of 18. That makes x approximately 4.22. But what I would do is I would store x in my calculator so I don't have to worry about rounding. So the area of the decagon is going to be 1/2 of the perimeter times the apothem. So to find the perimeter, what I'm going to do is I'm going to take 2 times x. That would be this entire distance. And if I take that and I multiply it by 10, this would be the perimeter of the entire decagon. And then I also want to take 1/2 the perimeter and multiply it by the apothem, which in this case is 13. And since I have x stored in my calculator, I can type all of that in, and I would get a total area of 594.11 units square for my whole area of this decagon. So thank you very much for watching, and I hope this helped.